Hi folks, we're going to take a look at question 13 from page 99. So what they do is they give us a function f, and they tell us that it has the form mx plus b, where m and b are constants. In other words, they're telling us that f is a linear function. So we'll keep that in mind. Then what they do is they give us a couple of conditions on these functions. It tells us that the limit of the function as x approaches 1 is 2, and as x approaches negative 1, the limit of the function is equal to 4. Okay. Now normally, if I were just to get this piece of information here, I can't make any conclusion about what the function value is at 1, because the limit notation just tells me what the function is approaching as x approaches 1. That would be 2. However, we know that this is a linear function. So we know that a linear function, first of all, has a limit at all x values, not only in the domain, but over all real numbers. Okay, and any value that I take, okay, the function values approach the value at a as x approaches a. Okay, now we talked briefly last time that we give a name to this property, and that's called continuity. We're going to see that lines are always continuous, meaning the limit is always equal to the function value itself. Okay. So, given that it's a linear function, and I know that the limit will always be equal to the function value, from this piece of information here, I can conclude that f at 1 must be equal to 2. Okay, and from this piece of information here, I can conclude that f at negative 1 has to be equal to 4. So again, I can only make these conclusions based on the given limits because I know a priori that it's a linear function. So a nice function whose limit is always equal to the function value. So from here, I have two pieces of information that are going to help me solve for two variables, in this case here m and b, so I should be thinking a system of equations. So let's input this here into the equation. So the y value, f at x is 2, equals m times x, which is 1, so just m, plus b. Okay, and then from the second piece of information, well, the y value is 4, and that's equal to m times x. In this case here, x is negative 1, so negative m plus b. Okay, and here we have a fairly simple system of equations, so we'll just, I guess, add them would seem the best thing to do. So this is 6. These cancel out, so we have 2b. So b has to be equal to 3. And then here we can pick that first equation, m is equal to 2 minus b, so 2 minus 3. So negative 1. Okay, so in other words, our equation is negative x plus 3. Okay, and if we want to do a quick check, if I put in x equals 1, I get negative 1 plus 3 is 2. And if I put negative 1, negative 1 is 1 plus 3 is equal to 4. In other words, that works out. Okay, that is it.